Good afternoon. Today we are going to work on solving algebraically. So if I was going to title these notes, I would say it is solving systems algebraically. I think I spelled that right. Solving systems algebraically. And today we're going to learn two methods. The first method is solving by substitution, and the second method is solving by elimination. I have just a little bit of a review here, which is solving by graphing. So as you might remember, we can solve by graphing the two lines. So I can see that I have the red line here, right, as 2x minus 6. And then I also have the blue line here, negative 1/4 x plus 3. So I know that a solution is where the two lines intersect. So it will be this point here. And I would say, okay, I'm going to label that with x and y. So I would have 4, 2. So I know that my solution is 4, 2 for this problem. I'm going to go ahead and solve this algebraically and use the exact same equations in order to solve it by substitution. So if I'm solving by substitution, what that essentially means is we're going to take one equation and put it inside of another equation, right? So the easiest way to start is to solve one of the equations for either x or y. In this case, I see that they're both just y equals something. And so my first step is already completed, right? I want to get one of the variables isolated by itself. And then my second step is to set the equations equal to each other. Since both of them are equal to y, that means that they must be equal to each other, right? So if both of these are equal to y, then when they're talking to each other, these must be equal to each other. So I'm going to say, okay, 2x minus 6 must be equal to negative 1/4 x plus 3. So I'm going to set them equal to each other. Step 3 is to solve for the variable. So I'm trying to get x by itself. I'm going to go ahead and add 1/4 x on this side. You know what? That's actually going to make things kind of complicated, and I don't want to deal with those fractions. So instead of doing that step, I'm going to go ahead and do what's called, I don't know exactly what it's called. I call it fraction busting. And in this case, since it's dividing by 4, I want to multiply everything times 4 so that I can use the whole number of negative 1. So I'm going to multiply everything here by 4. And what I do on one side, I need to do on the other side as well. So I'm going to go ahead and distribute in here. I get 8x minus 24. When I distribute in here, negative 1/4 times 4 would just be negative 1x. And then 4 times 3 would be 12. Right? That's that fraction busting. I don't want to have any fractions, so this works out better for me. So I'm going to have 9x. I'm sorry, whoa. I'm going to add 1x. My brain is already doing this next step. So that I would have 9x. I'm going to go ahead and add 24 at the same time. Adding 24, so I get 36 on this side. And then I'm saying, okay, I'm going to divide by 9. I get x equals 4. Right, so 4 is the x coordinate of my solution. Right? That is my x coordinate of my solution. I solved for the variable. And then step 4 is to substitute into either original equation. So I can decide whichever equation is easier for me. Personally, I'll just go with the one that doesn't have fractions in it. So I'm going to do 2x minus 6, y equals 2x minus 6. And I know that x is equal to 4. So I'm going to have 2 times 4 minus 6 is equal to y. So this would be 8 minus 6, which is 2. So y equals 2. X equals 4 and y equals 2. So my solution is 4, 2, which is great because I see that that solution is exactly the same as the one that I got when I was graphing. And since I'm solving the same system, then I would want to have the same solution. Okay. We'll do some more practicing with substitution in a moment. I also want to show you how to solve by elimination. So the first step for solving by elimination is to rewrite both of the equations in this format, ax plus by equals c. We talked about this being called standard form, which these equations are already written in that format, right? So 2x, y, and a number, x, y, and a number, right? So they're already written in standard form. It says multiply one or both equations so that either x or y is eliminated or canceled, right? So what I essentially want to do is be able to add these equations together. So I'd say, okay, this is 3x's, this would be positive 3y's, and this would be 18. But that doesn't help me because it doesn't get rid of one of the variables. So I want to put this in a more helpful version, right? So I can see that if I have a negative y and a positive 4y, right? So if I had a positive 4 here, that would be awesome because then the y's would cancel. If I want to have a positive 4 there, though, I need to multiply times 4. I need to multiply everything in that equation times 4. So I'm going to go ahead and multiply everything in this equation times 4. So I would have 8x minus 4y equals 24. So that's that first equation. Go ahead and write down the second one. X plus 4y equals 12. So now when I add these equations together, you can see, okay, negative 4y and positive 4y, that would make 0. And I'm going to go ahead and add these. 9x equals 36. Right, I'm starting to recognize this from the last one. Dividing by 9, I would have x equals 4. Sweet, x equals 4, okay? X equals 4. And then I can plug into, I solve for the variable that's left over. I'm going to substitute into either original equation. I'll just go ahead and do the first one. So 2x minus y equals 6. I'm going to take this and plug it in here. So 2 times 4 minus y equals 6. 8 minus y equals 6. Going to subtract y. I'm sorry, 8 on both sides. Negative y equals negative 2, which would mean y equals positive 2. Okay. So again here, I see x equals 4 and y equals 2. X equals 4, y equals 2. That is because these equations right here are exactly the same as this equation written in a different format, right? So all three of these are solving the same system and using 3 different methods. Okay. So let's do 2 more examples. I'm going to do one with substitution and one with elimination. So this one here, I'm going to use substitution. And the reason that I know that I want to use substitution is because one of the equations is already pretty close to being solved for a variable. In fact, it's already solved for a variable. We already know what x is, right? So x is equal to 2y's. So if x is equal to 2y's, then I could take, instead of writing this x here, I could actually write 2y in its place. So I could say, okay, this would be 3 times 2y, 3x plus 2y equals 2. I've written the same equation again, but I've substituted in 2y instead of x because x is equal to 2y. So I would have 3 times 2y would be 6y plus 2y equals 2. I'm going to go ahead and combine like terms. So I have 8y equals 2. Divide by 8. Get y equals 2/8, which I can see can be simplified to 1/4. So my y in this case is 1/4. And now I want to plug that in. I want to plug in that equation into one of the original equations in order to find out what x is. I think it's probably easiest to plug it in here since that's already solved for x. So I'd have 2y equals x. I'm going to go ahead and take this, plug it in right here. It would say 2 times 1/4 equals x. So 2 times 1/4, if I have 2/4 put together, would be this, 2/4, which I can simplify to 1/2 equals x. So my solution here would be 1/2, comma, 1/4. If you put both of these equations into decimals, you would find that they intersect at 1/2, 1/4. Just like that. So this would be my answer for this problem. So remember with substitution, we're getting one of the variables by itself. We're taking that variable and plugging it into the equation, right? The other method is elimination, and I choose to use elimination when it is set up in the case, set up in like the standard form, or if it's easy to put them in standard form. So in this case, I can see the x's are lined up, the y's are lined up, and the numbers are lined up. So this is a good situation for elimination. And I have to think, okay, how am I going to get these to cancel? I could do a -3 here, right? And then -3 on each of those. Or I could do a -2 here and multiply -2 for everything on the bottom. I have many other things I could do if I wanted to. I could really do like -6 here and then multiply this times 3 and multiply everything times 3. That would be much more complicated. So I'm going to look for my easiest situation. I like to multiply times 2. So I'm going to go ahead and multiply times -2 here, which is going to multiply times -2 here and multiply times -2 here. So everything's going to be times -2. So this equation becomes -2x minus 2y equals -12. I'll copy down that first equation here. 3x plus 2y equals 10. When I add them together, I'm going to do 3x minus 2x would be 1x. 2y minus 2y is 0. And then 10 minus 12 would be -2. And awesome, it's already solved. So I have x equals -2. Once I have that, remember, I'm going to plug it back into one of the original equations. So I'm going to go ahead. This equation looks easier. It just says x plus y equals 6. So I'm going to have x plus y equals 6. So I'm plugging in -2 plus y equals 6, adding 2 on both sides, y equals 8. So x equals -2 and y equals 8. So I have -2, comma 8, like that as my solution. If I was to graph these two equations in decimals or any other graphing calculator, then I would see that my solution is where they intersect, is at -2, comma 8. For today's assignment, you are going to put a picture of your notes first, as always. If you would like to, you can put your favorite selfie here. I put my favorite selfie right there, just in case you want to get to know me too. You're going to double check that you turned in assignment 9. You can check by clicking here. That will take you to assignment 9. You can check for that submission box. And then you have 4 options, right? You're going to choose one of them. You don't have to do all 4. You should not do all 4. You're going to choose one of them. If you would prefer to work on IXL, there are 2 options for IXL. One is a little bit easier. It just includes elimination. So just that second method that we learned today. So you can choose the easier IXL. If you would like to use both methods or somewhat more challenging, you can do option B. Both of those are equal. You're going to 9B in both situations. If you don't like IXL and you're like, womp womp, I hate IXL, miss, that is why I created option C and option D, which are on paper. So if you choose this, you're going to, if you want to do the easier problems, they're on pages 2 and 3. If you want to do more challenging problems, you can go to page 4. So I'll show you what those look like. Option C just has different levels. You're going to complete both of these problems and you should have the same answer. That's how you'll know that you solved them correctly. Solve these problems, you're going to have a common answer. You'll have 4 levels, so 16 total problems. This is for option C. And then you also have option D available, which is just a bunch of problems. So you're going to choose 16 of them. The answers are here and you'll put your work here. Right? So you're going to choose one of these options today. You're going to choose either the easier IXL or the more challenging IXL, or the easier paper or the more challenging paper. So you can decide which one works best for you. If you decide to do a second option, it will be extra credit, but a third and fourth option will just be awesome points. No more extra credit after the second one. All right. Whatever option you choose, you're going to highlight one of them here. Tell me which one. If you do a screenshot, put it here or here, depending on which one you do. And then if you're working on paper, you're going to click those links to add to the paper. Okay. Please come back to the main room and ask any questions if you need any help. Thanks, guys.